This is really good. As an example, to demonstrate for people here that don't believe, but you obviously should, because I mean it's not like an opinion, it's a fact. If you have a resistance here, right, because you had a bad connection, right, it's 2 plus 2 equals 4 ohms that, and then look at the current now coming through. It's only 3 amps. So things are starting to get dim, right? Things are not working properly, right? You have more resistance in the circuit. And that's just a simple circuit. There's no switch here, right? Think about all the different connection points. And a battery is certainly not connected to light. A battery is connected to an unswitched distribution bar. Unswitched distribution bar connected to a switch, to a positive switch distribution bar that's connected to a fuse, that's connected now to a switch somewhere else, a breaker that feeds a panel. That panel is then connected to a circuit breaker lights that's connected to a light switch that's then connected to a light. And the 6 butt connectors. So every single, I mean, if a circuit was this, it'd be pretty easy, right? There's not that many connection points. But every time you bring a connection point, it's another single point of failure. And you're going to have people that are going to be satisfied with, oh, it looks like it won't fall apart, right? And when you do electrical wiring, we're going to do a presentation a little bit later on, you got to pull the wire, make sure it's a really good connection before you apply the heat. Don't say, well, you know, don't touch it. I think it's good. Walk away slowly, right? You need to do a pull test, and it's like 20, 30 pounds pull test to make sure that you've got a good connection. A lot of people are just going to be like, careful, fragile, I think it's good, right? But that's 1 out of maybe 10 connection points on a whole circuit, and they all add up. That's why you want to make sure that you don't have any undue resistance. Use, you know, tin wiring, use tin gauges or tin lugs, use heat shrink, right? This is another example of things in series, but nobody wires a boat with loads in series, right? You don't do that. Nobody does that. Everything is parallel circuits on a boat, because what would happen is you'd be limiting every time the number of amps as you add every single device, right? And you look at what would happen with the voltage. Okay, so what you end up doing is you wire in parallel. That's how light circuits on boats are wired. Not every single light circuit goes back to the DC panel. It'd be crazy. You'd have a panel that would be the size of a door, right? You'll have a bunch of circuits, and think about some of those modern boats have 30, 40, 50 lights, right? They have lights everywhere. They're all parallel circuits. They might have one on a light switch for forward cabin, one for salon, one for galley, but they're going to be, a lot of them are going to be on these parallel circuits. And a parallel circuit is like this, right? Where you have the load is here and here, right? They're not in series. So that's how everything on a boat should be wired, is in parallel circuits. But you can see as you add more and more lights, like that fellow, remember that I was showing you? It's amazing, everything goes full circle. Remember I was showing you the fellow that installed those underwater lights? He wired them all with only one fuse. It was a 15 amp fuse. He wired them in parallel, which is what he should have done. But every time he was adding a light, the amperage was going up, right? So he had 75 amps going on a 15 amp fuse. And that's the reason why that fuse shorted, not open, but close, which is crazy, right? It's like suddenly being in an accident without a seat belt and you thought you already had one. And then the whole bundle caught on fire. So you can imagine how expensive that was. To replace a bundle of wire on a boat that is all melted, it's not something you do on a Sunday afternoon. Like it's called days. And it's not something you do yourself. Like, it's crazy. All right, so here we've got example. How would you find, batteries in series or in parallel? So here you've got a multimeter, and what we're showing here is you've got a multimeter, and this is set to an analog stage just because it's a nice diagram. But what I like about digital is they're going to find the voltage automatically. Like, it doesn't matter if it's a 20 volt range or 12 or 4 or 100. Digital multimeters will actually, you don't have to find the range. You just simply voltage. You don't have to know what voltage you're looking at. Okay, so it just makes things easier with a digital multimeter. This is called a rangefinder on the analog ones, but the digital ones you don't have to do that. You just simply say, I'm looking at a DC voltage. And if you do that, you measure, you put the multimeter at the positive end and the other multimeter at the negative end, and you can see even on this one, you know, the positive and negative end are obviously labeled positive and negative. Now, what would happen the first time, what voltage would we see if that battery was 12 volts on the multimeter? 12 volts. Now, what about on this image here? Notice the leads have been inverted or reversed. Negative 12 volts. Not 0. Potential is still there. It's opposite potential, right? So it's going from 0 to 12, not from 12 to 0. All right. So this is actually kind of useful because a lot of us have golf cart batteries on our boat. It's not uncommon, right? Golf cart batteries are 6 volts. They're useless in itself. You can't buy a golf cart one. There's nobody ever has 3 golf carts, right? You always in pair, right? You'll have owners that have 4 golf carts and in pairs because they have a 24-volt boat, but you know it's like 4, 8, 12, but they'll never have 11 or 7 because what do you do with a 6-volt battery? So if you've got a 6-volt battery, this is 1.5, it's just a standard AA battery, but let's say this is 6 volts and this is 6 volts. Remember there's a jumper wire, right? And that's common with 6-volt batteries. You're going to have literally a jumper from a negative cable, negative post, going to a positive post, right? It's very common. I mean, this is like 50% at least of all the boats have golf carts. It's the most common battery. And so they're in series. And so what's going to happen to 2 6-volt batteries in series? 12 volts. What about 4 golf cart batteries in series? No, 4. 24. Okay, now you've got 2 6-volt batteries and you put them in parallel. 6 volts. Yes, very good point. Very good point. Okay, this is good takeaway because that happens again a lot, right? You're going to be doing this all the time. This is a common problem, or you can help someone else if you understand this. And this actually sounds simple, but it's not that simple. When you have batteries and you put them in series, let's say you have a golf cart battery and it's 200 amp hours, and you put 2 batteries in series, right? So this is 6 volt, 200 amp hours, and this is 6 volt, 200 amp hours. An amp hour, we'll talk about that later, that's a unit of, it's a quantity, it's like a liter, okay? It's how much capacity it is. It's called capacity over 20-hour rating. But again, don't worry about that, it's just, remember it's capacity. 6 volts, you put it in series, we said the voltage would be 12. What happens to the amp hours? Stays the same. Stays the same. So 2 6-volt batteries in series is a 12-volt battery at 200 amp hours. Okay? When you put 2 6-volt batteries in parallel, what happens to the voltage again? 2 6-volt batteries, like in this image, stay the same. What happens to the amp hours? It doubles. That's exactly right. So for example, 4 golf cart batteries, right? If you had 4 golf cart batteries on your boat and you wanted a 12-volt battery bank, you'd have 2 sets of golf carts that would be wired in series because you need to get both of those batteries, both pairs of those batteries have to get you to 12, right? So then that's 12 and 12, both at 200 amp hours. Then you wire both of those pairs in parallel. Now you're still at 12 volts, but now the amp hour went to 400. Oh, absolutely, yeah, absolutely, absolutely. That's how you build capacity on a boat. Yeah.
In Calder's text, he has a funny way of tying 4 golf cart batteries together.
Yeah. Yes.
He doesn't do the traditional 6 and 6, but he actually crosses over. He says that.
Yeah. Yes. I've done that on my boat.
Okay.
I have, but honestly, that is so out there in the stratosphere of being picky, and I'm that person. Most people will not do that because A, they don't have the time or the money. It's just crazy. If you follow everything that Nigel does, like I have, I'm on my 5th rewiring of my boat because I'm seeking perfection, right? And it's never ending. There's no such thing as perfection. You can't, but I'm seeking it. You'll just find yourself chasing your tail. With Nigel, you want to do within a reasonable amount, maybe the 80%, and the top 20%, not that it's not great, is just either you don't have time or you don't have money. Now, if you have both time or money, or you have a lot of money, no time, that's fine. You can solve a lot of problems with money. Or you can solve a lot of problems with time, but generally both of those things are pretty rare. And so most people would bring it down a notch or two. And I have never seen, other than my boat, a boat that wired like that. I'm the only one that's ever done it.
It says they act as one.
Yes, 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 of course, yes. But that's easy with 4. Imagine now if you have 8. So again, not all advice needs to be followed on a boat in terms of perfection because it's just not realistic.
So the other way, series parallel is.
Well, that's how they do it. Series parallel is just more easier, and it's just at one point you got to balance. You know, if you're going to do that to that level, do you realize the other world of pain you've caused yourself around the boat? Because if you're going to go to the nth degree on that, that means you have to go nth degree on everything else. You're not just going to go one thing. You're going to go electrically. You're going to go to crazy, and then that means that your haul out or your time to go out on the water is not 3 years; it's 20 years, because you're going to be working every day to go to that level of perfection, and it's just not realistic. Do you know what I mean? It's
But that style of wiring for batteries, is it any better than just doing series
no.
parallel?
What he says is better for balancing the batteries. What he's doing is it allows the batteries to wear more evenly, but honestly, it's over the top.
It's overkill.
And yes, again, not that I listen, I did it on my boat, but I love to do electrical. Some people like to read a book and relax. My pleasure is making my boat better. That's how I derive pleasure, is I like to make it better. But that's weird, right? That's weird. And I have time because I like doing it. That's my hobby. So I would not recommend for most people to do that.
Wouldn't you be better off just buying better batteries in the first place and just running them in parallel? Like if you buy carbon full batteries
Yeah, they're 12 volts.
and you're at 12 volts,
Then you don't have,
worry about
yeah,
running series and you spend your money on
yes,
a really good battery and
yes.
parallel.
That's why I'm saying sometimes it's really important with advice that you have to put it in context. Right? Everything is, and there's no such thing as a perfect boat. People with endless money, no one has ever attained perfection on a boat because every choice has an implication. Right? So you don't want to follow a rabbit down you got to back off. So yes, there are arguments of saying the ideal battery is one battery, but the problem with that is the weight. Can you imagine one battery? 400, 500 pounds, right? That's the issue. And so the golf carts make it modular, easy to carry, and that's why people left 8Ds. And also golf carts are better built than an 8D battery for deep cycle applications. And so that's the reason why people, but again, a golf cart battery is great. Even though that limitation, I mean, worst case, you just change the batteries. They're not going to last you 10 years. They may last you 8. At the end of the day, like how much effort do you want to do to save your battery's 2 years life? Are you going to keep that boat that long? Is your horizon with the boat forever? Like all these things come at play as well. Yeah, go ahead.
If you're reading Nigel's book, how do you know what to disregard?
Well, that's where you can't, that's the reality. This world is becoming an expert world. I mean, that's why you're here today. You ask questions, you read forums, you have to. I mean, you think about a boat in the 70s and the 60s, you think about a boat today. It's unbelievable. It's a world of difference. It's like everything else, right? You can't, I remember reading that book, Nigel Calder. I've read it about 3 times. Every single time I read it, I learned something completely, utterly different, and I've read it cover to cover. And there's chapters in there are paragraphs that I never got, that I read, and I thought I understood. Now that I have the experience, I'm like, oh, right. But he can't delve into every single thing he says. That paragraph might have 10 amazing lessons that he can't put a footnote to footnote because his book is already this thick. And if he said everything he knew, it'd be this thick, right? So you read that paragraph, you're like, oh yeah, whatever. And then you read it after you've seen the problems out in the field, and you're like, oh, yeah, that is unbelievable. And so that's the whole point of that quest for knowledge. You always get better and better. But the reality is that when you start, you just generally, you follow most of the stuff, but don't go to the nth degree is a rule, right? Because you just don't have the time or the money. That's the limitation. So batteries in parallel, what we're seeing there, that's a little bit what we were talking about, right? What's going to happen to volts and amps, right? That makes sense. They're both in parallel because positive to positive, negative to negative, right? On this example. So you saw the voltage stayed the same and the amp hours increased, right? So I talked a little bit about, how resistance is a concept, but nobody's ever going to tell you the ohms of anything on your boat. So do not worry. Everything is really more about P equals VI. Power equals voltage times current. And that's really how things are rated, is about power, or they're going to not even give you the power rating, they're just going to tell you the current rating, which is current times voltage equals power, right? Because even power, you still have to do the math. Okay, so here are different examples. But think about how many people think about, okay, this you might know, because we talk about that. A lot of VHS will say 25 watts transmitting power. But a lot of other things on a boat, you don't know, like what's the wattage of a water pump? Anybody know that? Anyone ever heard what the wattage of a water pump is? Never. They don't talk like that. They talk in amps, right? They're going to say it's a 4 amp, 10 amp, right? They're not everything is watt. Light bulbs used to be wattage. But LED lights aren't anymore. They don't talk about watts, right? They're going to talk about amps. Now, yes, you could, of course, everything that has an amp has a watt, right? But not everything is talked about on a boat in watts. A chart plotter, they don't tell you what the watts are on a chart plotter or radar. They won't tell you that. They're going to tell you the amps. Oh, this radar draws 4 amps or 10 amps at maximum range. They're not telling you what the wattage is. Wattage is just good to know, and we were talked about that a little bit earlier, where watts, right? Because a load is a load, and that's not going to change. And if you have a decrease in voltage, you'll have a complementary or equal increase in current, right? So if you go from 12 volts and you lose 20%, your current is going to go up by 20%, because the appliance is always still drawing the same amount. So whatever you lose on volts, you have to make up on current. And that's why you start having nuisance tripping on windlasses, on certain appliances over time, when they're running at full capacity, under bad connections, because bad connections is going to cause a voltage drop. Right? So here's another one, right? Power, watts, equals voltage times current. And so the question is, why do we care? Well, we talked about earlier that amps are the rate at which something goes, electron flow, which is similar to speed, right? And the other thing too is what they're saying is amps vary widely depending on the voltage provided, right? Right? We know that. We've just said that. If you've got lower voltage, that's going to affect what amps you're going to get, right? Lower voltage, higher amps. Amps is also really important because amps actually is one of the big factors in deciding what gauge wire you can choose on a boat. There's 2 factors in choosing the gauge of wire on a boat. On house, and this is where most household electricians fail epically when they come on a boat, and it's not a coincidence. Homes are wired at 120 in North America and 220 in Europe, not by some random fluke because people didn't know what to do. They chose those voltage as a way to offset voltage drop. Voltage drop is something that's inherent in all circuits. It's like corrosion underwater metals. It's going to happen. And what they did is they wanted the voltage drop to be minimal as a proportion of the overall voltage. And the reason why in Europe they would have done 220 is because they knew that they were building to a lot of older buildings further away. And in North America, everything was green builds. They were new builds. So in North America, they got away with lower voltage because they knew their voltage drop would be not as bad as Europe. So when you wire a house at 120, they've made sure that the only real factor that's going to come into play in a house is not voltage drop, but amps. So you choose the gauge of wire in your house strictly on one variable alone. You go amps, 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 and that's it. I've got a circuit 200 amps, 50 amps, 20 amps, 15 amps, 5 amps, and you choose your gauge of wire strictly based on amps. On a boat at 12 volts, and nobody built a boat at 12, and no engineer would have ever come up with a 12 volt boat, ever, because it's too low of a voltage. And it was 12 volts for a car, and think about how tiny a car is versus a boat. And think about what a car runs versus a boat. And the only reason they did that is because the boat came with an engine. The engine was a car engine, and the car engine had a car starter, 12 volts, and had a car alternator, 12 volts. And the only thing that boats had back then were a light. So it kind of like, well, you know, it works. Car's 12 volt engine, 12 volt alternator. We got to start it anyways, and we're going to run a light on a boat. Because boating back then was camping. I can tell you, my boat is not camping. And most of our boats here are the last thing there is to camping. Camping is a long time ago. And if you have a boat that's like a camper, you probably don't even need electrical, because the only thing your boat does is start, and you might not even have a light, right? And then that electrical is pretty much gone, other than a starting circuit, which goes back to a car, which is dead simple. But if you have not a modern boat, a normal boat from the 70s or 80s or 90s, you do not have a camping boat. You have refrigeration. How many cars have refrigeration? Right? How many cars have, like, and nowadays, think about all water pumps, heads, right? Think about heating systems, all these things that are crazy added on top of another. And so what happens is the voltage drop on a 12 volt boat is amazing, because the runs are super long, right? Car is tiny. Everything's at the front of the car, right? All the loads are right beside the engine. Think about where your batteries are on your boat and where are your loads. Some boats on Jeanneau's, Benetto's, the batteries are in the back in one of the aft cabins. Some of the big appliances are the windlass. How far is the windlass? And that's 40 feet one way at best, right? And then return, plus the connections. And that's kind of if you're like really lucky and that's a straight shot. If you've got to go up, down, it could be 60 feet on a 45-foot boat for one way coming back. The amperage of the cable is not going to be the limiting factor. The real limiting factor, I'll get to your question, is the voltage drop. It's all about voltage drop. And so when you choose the wire on your boat, it's not just about amperage, which yes is a limiting factor, but unfortunately it's the second thing that matters the most at 12 volts. It does matter, but the real limiting factor is actually voltage drop. And then you end up sizing a wire based on, there's two tables, but the table that ends up choosing the wire that is the real weak link is the voltage drop. And that's why wires on boats are so big. And that's why builders went to 24. At one point thought about going 32, right? As a way to offset the voltage drop by having smaller and smaller wires. And on big boats, like we just finished a 145, not the whole thing, but we did like a lot of work on that boat. That whole boat has practically no DC on that boat. They don't put DC on big boats. You can't. It's not practical. They'll have small DC circuits. Everything's localized, but the boat is running on AC. I mean, there's DC circuits, but they're tiny. All the boat is just generator run. Everything is off generators. Well, you have to. You can't have I mean, these are not houses, they're buildings. They're the size of this museum, right? You can't run a boat like that on 12 volts. The voltage drop would be insane. They run it like we do on land, 120 or 220, right? Because the lines are so long. By the time you leave the generator and you go to the bridge on the 4th level up front, that run might have been 300 feet one way, right, to get there. So voltage drop is a really big, that's the differentiating variable that you need to really always worry about. And most household electricians or those experts, you know, the guy that you hire to work on your boat that worked on your home and that is giving you a great rate because he's an electrician and he knows everything and he's infused with knowledge, doesn't realize that on land they removed a variable to make his life easy. He doesn't understand that because he's habit. He never looked at voltage drop because he never needed to, because they removed that variable by increasing the voltage to 120. So he goes on a boat and he's like, and then he makes all the decisions based on current alone because he's in the habit of just doing current. And that will not work on a boat. So you had a question?
Yeah, you kind of covered it, but then when you buy some of your appliances, pumps or whatever, they give you, if you run so far, you need this certain diameter and a certain diameter. But if you don't have that, is there a formula for determining wire?
Yeah, absolutely. There's a formula. There's actually Blue Seas as an app. So if you have a smartphone, there's a full-on app. It's going to say, download it, it's free. And you're going to say, okay, is my load intermittent or fixed? Is my voltage 12, 24, or 36, or whatever it is? Where's the wire run? Is it running in an engine room or not? Because depending on where. Is it run in a bundle or not? What's the type of jacket that I have? So you would buy a nominal jacket wire because there's different insulations, right? It sounds complicated, right? It is. Like, that's why some of us make a living out of it, because it is complicated. But you want to do electrical, that's what you have to do, right? You got to get into it. Then you put all those variables in, and then they're going to say, do you want a 3% voltage drop or a 10% voltage drop, depending on the appliance? And you've got to make sure it includes the whole run, right? And then you put it in, and it's going to tell you the gauge wire. And then you're going to say, my God, that's ridiculous. That's what your first realization is, to be like, oh, that app is just broken. That's just crazy. I've seen windlasses wired with gauge 4 wire on a 40-foot run on a 1,500-watt windlass. Now that's crazy. The owner thought that the price of buying that cable was crazy, but then he also complains that his windlass doesn't work, and he's burning motors all the time, and it doesn't have power, right? Unrelated, by the way, to this decision of buying a 4-gauge wire. Like, those things were totally unrelated decisions. But suddenly, like, to us, it'd be like, well, no, actually they are related. You decide to wire your windlass with gauge 4, hence you're having all these problems. It's not a coincidence, right? So it's really essential that you actually buy that app. There's tables, there's charts. You've probably seen West Marine. You know, it's like, here's my amperage. Are you running it in a 3-conductor or more in engine room? What is going to be the temperature? There's 6 different tables, and then you cross-reference the 2, and then you go and you say, at that point you need a 1/0, or you need gauge 14 or 12. And you're supposed to look at both from either voltage or amperage and choose the wire that is the biggest of the 2. But what you're going to realize is that beyond 9 times out of 10, the table that decides voltage is the one that is going to be the biggest factor, or that's going to get you to buy the bigger wire or install the bigger wire. Yes, question here, and then a question over there.
So, like, I bought a washdown pump.
Yeah.
And I looked at and I think based on the calculation, it came up with 8-gauge wire to put it on.
Yeah, it's not crazy.
But the wire coming off the washdown pump might be 12 or 14 or
14,
like,
yes.
It's hardwired in.
So,
I can't change that.
so exactly. So what do you do? I have a solution.
That's why I'm keeping it as short as possible.
No, terminal strip, where you terminate your 8-gauge, and then you bring your 14-gauge right beside. Because the wire, the 14-gauge is going to be able to handle the amps, no problem, of the water pump. You want the length of the wire to that point to minimize the voltage drop.
So I'm not just going to use butt connectors.
No, but you can, because how would you connect?
How am I going to connect?
That was a trick question. Did you see that? We're not going to let that one fly. No, we are not going to use a butt connector on a gauge 8 wire to a gauge 14 or 16 wire. We won't, right? We will go to a no, yeah, right. And cramp really hard. Or actually just, you know what? The best strategy with the electrical is hope. You just got to hope. Hope for the best. Don't even prepare for the worst. What could happen? I mean, like, realistically. And so you would bring terminal strip. That's why you would do. You would bring it to a terminal strip.
A terminal
Strip is,
is like a panel that has 2.
yeah, so you can buy, I have on my boat, believe it or not, I mean, of course, I'm crazy, but I have little zip locks of tons of little terminal strips of different sizes. I'll have terminal strips that are made for, let's say, 20 amps, 2, 4, 6, 8. And then I'll have some for 30 amps, 2, 4, 6, 8. Then there's some that are 60 amps, 2, 4, and they're like the number of terminals, right? So that you can do, sometimes maybe you want to have, like on his application, it's easy. You just want probably, because number 8 gauge is going to have to fit on at least a 60 amp terminal. Even though you're not running that, the terminal itself is big. So you'd have a 60 amp terminal strip, even though you'll never run 60 amps, but the lug size is going to be big. And then you'd have that, and then you'd have 2 wires, positive and negative, and 2 wires, positive and negative, coming together. And then you'd not leave that hanging midair. You'd affix it somewhere. And the great thing about a terminal strip is, guess when it's going to be time that your water pump is giving you grief, right? And it's intermittent. You can actually take a multimeter, put it right on the terminal strip, and measure the voltage at the pump. Amazing, right? Because now you know what the voltage is at the pump. Not the voltage of the battery, which is completely different when the pump is running under load, right? So terminal strips are great. They're great. And builders, like expensive builders, put terminal strips everywhere on boats. Everywhere. Yeah.
I have no idea what a terminal strip is.
It's a terminal strip. You've probably seen them. I'll take a picture after I'll put it up on the slide. I'll show you when you come back. I'll find an image on Blue Seas. Generally, they're black. They've got 2 screws. So like a 20 amp would have 2 screws on each top and bottom, so that you can actually put 2 ring connectors that are going to be basically shorted together. There's going to be conductivity between the two. And there's an insulator in between the two for another set right beside it. So it's a way to join 2 pair of wires, right, on something that you can have ring connectors, not butt connectors. Because how do you join an H gauge wire, right, to a gauge 16 wire? How would you do that? You would do that on a terminal strip. I'll load that up, and at this after lunch, I'll load up the videos about fusing, and I'll show you on the Blue Seas website. And these are not expensive. This is like $3, $4. Like a butt connector is like a couple bucks. So it's not like, yeah, you're going to have to put ring connectors, but doing it right for a water pump means that now you have a serviceable point. And when your water pump will die, which by the way is going to happen all the time, why? Because of voltage drop. What you end up doing is you just unscrew 2 fasteners, take the water pump, and when you get the new one in, the other 2 wires are already there, just waiting. It's a serviceable item, easily serviceable. And you're not adding a butt connector to a butt connector, which we saw in the images below is what people do, right? Which is the reason why the pump failed in the first place, is because the connection on the butt connector was bad. Then the wire's not long enough, so they add another one and they're like, oh, I should have made it longer, but now with the butt connector, I'm going to solve. And then it fails again, and then they add a third one, and then domino.
So where do you put the fuse then?
Good question. Fuse, you fuse 2 things. You always either fuse a wire, well, not or. You have to fuse a wire, and you have to fuse an appliance.
So we fuse the 8-gauge wire too.
Yes, and you could, because normally water pumps are pretty specific about the fuse they want. So you'll end up probably having a fuse right at the terminal strip, right? It's going to be circuit breaker, 15 amps, let's say, on an 8 gauge, no problem, right? The 8 gauge can take 50. All the way to the terminal strip. Terminal strip is going to go to the fuse that came with the water pump, and then the water pump wire is going to go into that fuse. So then you've got a 15 amp breaker that should never, ever, because the fuse on the water pump is only 10.
That's the fuse on the 8-gauge is the circuit breaker.
Correct.
And then the inline fuse is off.
Correct. You can, of course, if, let's say, for example, I buy fuse blocks, you could have the line at the beginning of the circuit be protected with an 8 amp fuse, and the gauge 8 wire and the gauge 14 wire would be protected with only 1 fuse at the beginning of the circuit. That is mapped to the rating of the pump, right? You just want to make sure that you don't overfuse. You just never, underfusing is fine because the fuse is going to break. You just know never want to overfuse. So you would take that 8 amp fuse and you would move it at the beginning of the circuit. It would protect the whole wire and the pump itself. Yes?
So to continue on, when you say circuit breaker 15 amp, you're talking about probably the switch at the electrical panel.
Correct.
Being the circuit breaker. That's
Yeah.
where you first put it.
And that would be for the line.
Yes, for the line, yes, yeah.
I love the questions. I think we're making progress here. All right, and then you had a question in the back.
No, it was answered.
Answered. We're almost done. I know it's 12:38. We talked about that. We talked about that. So voltage times current equals power. We did mention that. Hair dryer. So you can see, right? Wattage divided by voltage equals current. So if you have a 3,000 watt inverter and you're running on 12 volts, guess how much current you're going to be pulling through that? Massive amount of current. Massive amount of current. Or the other one that's really good is, this is actually a really good example. And I have this all the time. Owners ask me this all the time. You can replace that hair dryer with even a small heater. ceramic heater that are commonplace, 1500 watt, 1200 watt. And they say, Jeff, I need a battery bank to heat my boat. And I'm like, okay, I understand. Yes, you want that. I also would like a Bentley coupe. Personally, that's my taste. I want that. But let me tell you why you can't have what you want, and you know why I can't have the Bentley coupe. If you've got a heater that draws 1200 watts and you're running it on 12 volts, well, it's 120, but then you've got to convert. It's 10 amps at 120, but you're not running it off the batteries, you're running it off the inverter, right? So you go 1200 divided by 12, assuming your inverter is efficient, which it isn't, but let's assume it is, you'd be drawing 100 amps off that battery bank. How long is a battery bank going to be able to sustain a burn rate of 100 amps? Like, yeah, exactly. It'd be like, literally, the analogy, a perfect analogy is taking bills of money and putting them in the fireplace. You can create heat from paper bills. You can. It's probably illegal. I know in the States it's illegal. But let's say that you were allowed to do it. You can, yes, you could warm yourself with more money, but your battery bank would have to be absolutely astronomically huge. It would have to be, it'd be the size of your boat. You don't heat a boat with electricity. You just don't. And in Europe, it's not a coincidence that most places other than North America or Canada where electricity is cheap, I didn't understand this when I was growing up. I was like, why do people care about the price of oil everywhere in the States? Why does it matter? Why don't they just plug in? Why are they using heating oil? Like, don't they have electric baseboard heaters? Well, everywhere else, electricity is expensive, right? And so nobody heats homes with electricity. They use natural gas. They'll use heating oil. So imagine a boat with electricity. If people in North America and in Europe don't use electricity to heat up their homes, imagine what is the possibility of heating up your boat with electricity. It's just, it's impossible. And so that's what happens when people leave those ceramic heaters on an inverter accidentally for a few minutes or an hour or two while they're away from the boat. They leave the boat and they left the inverter on, and then the heater's on, but they lose power. The heater will run for 2 hours, kill the batteries, completely drain them. The batteries won't get charged until someone replugs or they get power again. And then what's going to happen is they'll lose their battery banks. And so I have tons of my clients, happens all the time, that have battery banks that are only a year old or 2 years old, that their battery bank is gone because they left the inverter on.
So if you had a genset and you're able to...
That's no problem. Yeah, absolutely. Of course, and that's how they do reverse cycle. Like air conditioners, which are common on most boats. I mean, it's because most boats have to boat in a warm climate, unlike BC. All these power boats have AC, and a lot of those boats here will maybe not have a diesel heater system. They'll do, the genset is going to reverse a cycle, right? Yeah. All right, so you can see what the voltage is, the difference of the voltage for a windlass, right? 1200 watt voltage, or 1200 watt windlass over 12 volts equals 100 amps. But notice if you've got now, you're running the engine. This is really important, people, just before lunch. If you've got a windlass on board, you should run your engine when you're running your windlass. Because look at then what happens. The current just went down, right? Now here's the point earlier on is why do people wire, Nigel talks about, if I was building a boat now, everything would be 24 and I'd have some loads at 12. I mean, from scratch, my dream boat would be 24 volt boat, for sure. Because look at now what's happening. 1200 watt windlass over 24 volts is only 50 amps. Do you know how much you save in wiring and weight to wire a boat in 24? It's amazing. Only very few appliances are 12 volts now. So what people are doing is they're buying DC to DC converters. They'll buy its converter, it takes 24 volts. They won't even have a 24 volt bank, a 12 volt bank. They'll just have the bridge, whatever needs to be at 12, they'll have a converter that converts 24 to 12. So a lot of the bigger boats are doing that now. They're just going DC to DC converters. And so they're running everything on the boat 24, and then whatever appliances only run on 12, which are getting rarer and rarer, they get DC to DC converters. Look at the halogen light bulbs. Look at the draw on those things. 4.2 amps. Your fridge is about the same thing. I have some owners, when they put on their like 50-foot trawlers, 48, they put on the lights in the salon, it's 40 amps. Can you imagine? Now you can run that, of course, when you connect to shore power, right? But imagine running that on Anchor, right? So that's the first thing you've got to do as a boat owner is you've got to get rid of all those halogen light bulbs that you're using, wherever they are. And there might be some that you never use, so it doesn't matter. But any ones that you commonly use, you've got to change those to LEDs. And LEDs is like 1/10 of the draw. Can you imagine if I tell you that you can reduce your spending by 1/10? Like literally 9/10 of it is gone. Your cost of living just went from whatever it was to 10%. I mean, electric lighting used to be a big issue and people had habits of turning it off. With LEDs, it doesn't matter. There's people that actually don't turn their Anchor light because it draws too much power, right? Or they'll turn it late at night when it's too late, or they won't turn it on at all to save power because the Anchor light might be drawing 1.5 amps, right? 1.5 times 10 hours, that's 15 amp hours. That's a lot. Some fridges, efficient fridges nowadays, are 30 amp hours. That's half the fridge for your Anchor light. You put a LED light bulb, it's 1/10 of that. Not 15 amp hours now, 1.5 amp hours. Guess how often my Anchor light is on my boat? All the time. I mean, 6, 7 o'clock, it's starting to get dark. I'm like, oh, turn it on. Next morning, around 8, wake up, oh, turn it off. Because it doesn't draw anything. If it was an incandescent light bulb that was drawing 1.5 amps, not 0.15, I'd be turning that thing off all of it. I'd be like, as late as possible, as early as possible, because it adds up, right, for that extended period of time. All right, we talked about DC current. That's from a battery. We talked about that. That's pretty obvious. And alternating current is, on boats, is either connected to shore power, connected to a generator, or an inverter. And AC is everything around us. Pretty much those wall outlets, these devices over here, right, they measure AC, right? So AC is creature comforts on a boat, generally speaking. For most, especially sailors, right? So that's going to be like a microwave. That's AC driven. A blender, coffee maker, TV. Those things. Now, on bigger boats, what they'll end up doing is they're going to have a genset and they're going to have an AC water maker. You can buy a DC water maker, but they don't output as much. So people are buying AC water makers, or they're going to put dive compressors, right? So you have a lot of appliances. Some people have dishwashers, garbage compactors. They have, some people have literally air conditioning systems. Air conditioning systems run off AC. So there are, generally you would associate anything AC is a comfort thing. It's a nice to have, not an absolute. And generally DC are things like lights, water pump, your fridge. Although your fridge can work on AC too, but most marine fridges have both. So generally DC are things you need, and AC are things you'd like to have. And so alternating current is, and we'll talk about that with inverters. There's differences between modified sine wave and true sine waves, and we'll talk about that too. But on most boats, it's at 120. Yes, there are inverters that output 220 as well, like Europe, but most of us do that. And here the hertz is 60 versus in Europe is 50. And that's a big issue and definitely not part of a kind of a introduction to electrical. But there are implications of taking a European-based boat that is meant to be run off 50 hertz for their appliances versus 60 hertz. All right, and we're going to call it for lunch. Thank you, everyone.
Thank you.
Get started. So I had talked about starting off with a few little demos on fusing and the importance of fusing. We're going to talk about wiring a little bit later because we talked about insulators, but I thought maybe to break the lunch here. There's going to be 4 videos. So this is a fuse right close to the battery. So you can see, imagine this is actually the battery right here, and you have 2 wires running in parallel. So what's going to happen when you cause a dead short on that wire?
With no fuse you're talking.
There is a fuse. It's right here. The fuse is right there. right? So what did we see? I mean, these are large cables, right? So first thing, that's like, I think it's 1 aught. There's a battery switch here, and there's a fuse right there. So we've got exposed wire, and we simply put any sort of fastener. It could happen on any boat. A dead short, and you notice the light was on, and it turned itself on. You saw a little bit of spark, but basically the circuit was rendered off when the fuse instantly blew, okay? Any questions about that demo? And what we're seeing there is we're seeing a fuse at the beginning of a circuit, right? Any questions on that?
And fuses always go on the positive line?
Common practice. Doesn't matter. You could have fuse on positive or negative. A circuit is a circuit, right? Some chargers actually fuse both positive and negative. Common practice, you fuse on the positive. It's a circuit. It really doesn't matter. The problem with the negative is you'd have more of the circuit energized. Yeah. Okay. All right. So this is fusing number 2. Now here's where it happens a lot. So we've got a fuse location. And this is the start of the circuit. See, no fuses here. No fuse at all. And we have a fuse right beside the appliance. Now notice, this is how VHF radios and everything else is wired, right? There's no fuse at the beginning of the circuit. The fuse is right beside the appliance. Now look at what happens with a dead short. That's 2 feet, 3 feet of wire. The wire melted. Do you see how long it took? Do you see the smoke? By the way, imagine, this is when people tell you they're doing maydays and they can't breathe and they have an electrical fire. An electrical fire is the opposite of a campfire with marshmallows. Okay? There is no element, oh, it's burning, it's glowing, it's pleasant, oh, I see a fire. This is not a fire in a garbage can. Okay? The amount of smoke within, we did it in front of our shop, from here to that table, it was already the size of that door. Like, that's how big the smoke was. Like, it started off the camera, we had it on the ground. By the time it reached just right here, the smoke was already this thick, this big. By the time we reached there, then it was probably double the size of that door. You can still see through any of it. By the time we're at the last table there, it was the size of a barn door of smoke. That's how concentrated the smoke was. Now remember, that's a dead short on a 2.5 foot run on a gauge 14 wire. So imagine how little insulation is on that wire. It's tiny. How short the wire run was, right? Some of your runs are not 2 feet. Some of your runs are 15 feet. Water pump, 20 feet, right? Going everywhere, running beside water tanks, beside engine harnesses, right? We had a job, CNC, had a short on one of their solenoids, their glow plugs was left on. Like sometimes they short, right? The glow plug switch. It shorted the whole wiring harness. You should have seen the smoke. They thought they were going to die, literally. The amount of smoke that was coming out of that engine room and out of the cabin was, you couldn't even breathe. Like you were off the boat, your face towards the water as the smoke was just billowing out of that boat. So that's a fuse, but a fuse placed near the appliance, no fuse on the wire, right? Because if you have a short, and you have a short that happens before the fuse, your fuse is irrelevant. That fuse, by the way, never blew because the short was before the fuse. Right? So that's essential. The location of the fuse matters. All right, now this is really common. 2-size wire, right? It happens all the time on a boat. Wires start big and get smaller over time. So you got a large fuse. Getting to, that's just a post. It's a small fuse going to a light. So what's going to happen when we're going to cause a dead short near the light? That's right. Right. So that's exactly right. The small fuse blew. This fuse here blew. Okay? The next one, which is this one over here, they both have a fuse, by the way. There's a fuse you can't see right here, an A&L 150 amp fuse that's rated for this wire. Okay? So now the next circuit. So now you've got two wires, right? Happens all the time. Every boat's got this. It's all starts with a large cable, large fuse, 150 amp, gets to your panel. Now you're connected to a light. What happens when you cause a dead short on that? Remember, there is a fuse on that circuit.
It's on the wrong side, isn't it? It's still gonna burn.
The fuse never blew.
No, it's on the other side.
It's just big. It can handle it. It can handle 150 amp. This wire here can't. You can actually see the wire melted again. That's right. Well, this is smaller, but yeah. So again, notice how a fire is not a fire, right? Because honestly, when I have connotations of fires, having spent a lot of time, camping and stuff like that, that's kind of, I'm not scared of fire. Actually, fires don't scare me. That's fine. Well, the problem here is the smoke. And it's not like white smoke from a fire, from wood burning. It's the jacket, the insulation from the wire. And it's so toxic and it's so opaque that you can't see anything. That's the issue. It's not the fact that you have a fire on top of in the galley and you're seeing it and it's in flames. It's the fact that when you have an electrical fire, your whole boat is going to be pitch black. You won't see a thing. You'll have no idea where you are. You won't see anything. You can't breathe and you can't see. And that's on a gauge 14 wire. That's nothing. Imagine when it happens on a gauge 2, 0, 1 aught, where the jacket is literally 3 mils thick. The wire will never, it's going to take a while before that wire melts off. Right? Imagine the amount of smoke that would take off a 10-foot run on a 1 aught wire. It would be a life event. It's a tsunami on your own boat.
Okay, can you just review what the best scenario is?
The best scenario, there's 2 scenarios. There's 4 scenarios in total, 2 are the best. One is you always want a fuse at the start of the circuit.
So that's right close to the battery.
That's right. That's exactly right. And the second scenario is a caveat of that, or a permutation on that, but you always have to fuse right near the battery or the source of power. That's in the most simplest forms, right? If we had a simple little canoe with a battery and a light, something very simple, you'd go back to the battery. There'd be no distribution panel. You'd go to the battery. So every circuit to the battery would be fused. Pretty straightforward. Because you have to protect the wire. The second video that we saw, we had no fuse on the wire, only a fuse on the appliance. I.e., like a VHF radio, like a lot of things, the fuse are connected directly on the appliance. As an installer of that equipment, the manufacturer of the VHF presupposes that you have a fuse on the segment of wire leading to the connection of the VHF fuse, right? It assumes that you know what you're doing, right? I mean, it's not selling you an electrical system, it's selling you a VHF, which is part of an electrical system. Yes?
So, if on most boats, so you have your main power running to your panel, and then that's got a breaker, which is essentially your fuse,
Well, it has multiple breakers.
or multiple breakers, but that's, let's say, your VHF. So you're
Yeah.
running a power source from your battery, ideally to your breaker panel, which could be 8 feet. Or
Correct.
more, 10 feet.
Yeah.
That's your only fuse then between that and, say, your VHF, which is maybe only 2 feet away from that.
So, all right, let's talk. There's multiple things here. First thing, if it was connection to a DC panel, there should be a fuse at the beginning of the circuit from the battery to the panel. There should be some sort of fuse. There has to be. That's a black and white. It's not an option. It's not a matter of conjecture. It depends. there has to be a fuse. There's a code, it says, depending on the length of distance, but 8 feet definitely means there's got to be a fuse within like super close to the battery that's going to allow you to run everything on that panel. So it might be a thermal circuit breaker that's 100 amps. It might be whatever, A&L fuse that's not serviceable but runs 100 amps. Whatever the gauge of wire that feeds that panel, right, and will not cause nuisance stripping is the fuse you're going to put on there. So you need to choose the fuse so you don't have nuisance stripping, but not bigger than the wire size can handle. You get to the panel. Then the panel becomes a distribution point. That distribution point is going to have multiple circuit breakers. Circuit breakers actually don't come in all different sizes. They're pretty fixed. 5, 10, 15, 20. There's probably 25, I haven't seen one. 30, 40, 50, but that's pretty much it. Then the line connecting that circuit breaker needs to make sure, let's say for example, you have a 15 amp circuit breaker, you need to make sure that that gauge of wire going to that panel is no smaller than 14 gauge, right? Because if it's 16, you're not protecting the line, it's too little. 16 gauge is smaller than 15 amp. It can't handle 15 amp. So you need 14 gauge or bigger. Like on my boat, I do everything in 10. Because why? If I'm going to run a line, I'm not going to run it twice later on because I have a bigger pump. I run everything bigger than I need. And then when you get to the pump, which we were talking earlier, then at that point, the manufacturer is not going to say, I want a 5 amp or 10 amp. He might, or they might, but they might say, I want an 8 amp fast blow fuse. Your circuit breaker doesn't give you that. I mean, it's 5 amp, 10 amp, and you can't say, well, they said 8, but they don't know what they're talking about. I'm an expert, so I got this, right? You can't do that. So what do? You go, okay, now you put an inline fuse that came with the water pump right near the water pump, and now your whole circuit has literally 3 fuses on it. Has a fuse at the battery, 100 amp, going on a large gauge wire, going to a distribution panel, going on a 10 amp breaker, going on a gauge 14 wire, going to a fuse that goes to a pump. And that's how it's done. If your appliance is for some reason maybe a 10 amp fuse that can work off a circuit breaker, then maybe, depending on how sensitive that appliance is, and they're not very specific in their type of fuse that they want. Remember, not all fuses are equal. There's slow blow fuses, there's fast blow fuses, they're all different types of fuses. Some of them are 7.5, 6, 4, 3. They're very specific.
Put them on a red or black.
A red. Red.